to the fourth video in this Tau for Trig series. Let's talk about graphing angles. In general, we use the Cartesian plane when we are asked to graph angles in standard position. Here we have our plane. The initial side of our angle lies on the positive x-axis. Next, we have to determine where the terminal side lies. For now, let's say it's here. The angle that's created when we move counterclockwise from the initial side to the terminal side is our positive angle, and the angle formed when we go clockwise from the initial side to the terminal side is our negative angle. In the next few examples, let's start with an angle in degrees. We'll first convert it to radians for practice, and then we'll graph it. The first example asks us to graph a 90-degree angle in standard position. You might remember from a previous video that in order to convert, we multiply the angle in degrees by tau radians over 360 degrees. In this case, we get tau over 4 radians. To graph this, we start with our initial side here. Now draw a line to the terminal side, which is tau fourths radians away in the counterclockwise direction. And that's it. Let's try 120 degrees. I'll let you do the multiplication here to convert. You'll find our angle converts to tau over 3 radians. One neat trick you can do with certain angles is to think about them as a fraction of the whole. Since one rotation around is tau radians, you can break up this graph into 3 equal parts and find your terminal side 1/3 of the way in the counterclockwise direction. Alright, we also graph negative angles by first starting out at the initial side, but moving clockwise to our terminal side. In this example, our angle is given as negative 45 degrees, which is negative tau over 8 radians. You can use either method to figure out where this angle is, but I think you already know that tau eighths is half of tau fourths. So starting at our initial side, we move here to the terminal side. I think we have time for one more example. The angle negative 210 degrees converts to negative 7/12 radians. This is a good one to use our trick on. We first break up the graph into 12 equal parts. What does negative 7 tau 12ths tell us? Well, it says that we are moving clockwise from the initial side until we've covered 7 out of the 12 parts. And that's our terminal side. You can graph any angle without breaking them up into equal parts. Just remember, if you do use this trick, it works best for angles in radian measures that have a 12, 8, 4, or 3 in the denominator. That's it for now. Thanks for watching, and don't forget to check out our upcoming videos on trig functions and trig intervals.